Hello everyone, welcome to chemistry class. Today's topic of discussion is the Rutherford's model of atom. Having discovered the fundamental particles, that is electrons, protons and neutrons and their properties, now we have come to a stage how these protons, neutrons and electrons are placed inside an atom. So that is what we call as structure of atom. So we will have different models that explains the structure of model. The first model that which gives the concrete proof of these fundamental particles inside an atom is Rutherford's model, because he was the very first scientist who gave the concrete idea about this model, the structure of atom. So we have Rutherford's model. Now this Rutherford's model that explains the structure of atom, the name of the experiment is known as alpha particle scattering or alpha scattering of gold foil. So the name of the experiment is scattering of alpha particles when these are passed through a thin metal foil and the metal is made up of gold. So the name of the experiment is alpha scattering of gold foil. So we have used a particle which is known as alpha. So alpha, this alpha particle is nothing but helium nuclei. This helium nuclei is known as alpha particle. So positively charged helium nuclei is known as alpha. So we have a positive charge. This positively charged alpha particle is made to pass through a thin gold metal foil. Now, why selectively gold was used? So we have a number of metals. So instead of all these metals, selectively gold was used by Rutherford. So there are basically the reason for using gold for this alpha scattering experiment is gold is the most malleable metal. So he wanted to make as thin as possible the metal foil that used in this experiment. We wanted as thin as possible. So the gold being the most malleable can be made as thin as possible. So this was the reason why selectively gold was used. This was most malleable metal. So gold being the most malleable metal, the metal foil can be made as thin as possible. So this was the reason why gold was selectively used for this alpha scattering by Rutherford's model. Now the question is, if lighter metals like aluminum, which is also malleable but not as malleable as that of gold. So if lighter metals are used, what will be the change or effect in this alpha scattering experiment? Now lighter metals will have less positive charge, lighter positively charged nucleus inside the atom. So these lighter metals having lighter or positive charged nucleus will undergo less deflection when these alpha particles were passed through the metal foil. So alpha particles are heavier particles than positive helium nuclei. So the helium was a massive substance. So when this massive substance is passed through lighter metals having less positive charge, so the deflection would have been less. If the deflection would have been less, then observation would have been slightly different. So instead of these lighter metals, heavier metals containing heavier nuclei. So heavier nuclear atoms will contain heavier nucleus that is positively charged. So these would undergo more deflection. So result can be easily obtained. So this was the reason why lighter metal was not used in Rutherford's model of explaining the structure of atoms. So we have this diagram. This is the experimental setup. So in this experimental setup, we have a thin gold metal foil. Behind this thin metal gold foil, we have a screen or a photographic plate. This photographic plate is coated with zinc sulfide. Now, why this photographic plate is coated with zinc sulfide? Zinc sulfide is a when these alpha particles, after passing through this thin metal foil, will strike the photographic plate. So when these strikes the photographic plate coated with zinc sulfide, a glow will be produced because it's a fluorescence compound which produces glow when someone strikes. So alpha particles striking the photographic plate coated with zinc sulfide, so there is a glow at the point of strike. So from this we can easily measure the particles. This is alpha particles. These are the alpha particles after passing through the metal foil without changing its direction. That is, no deflection is produced by these alpha particles. There are some alpha particles which produces deflection from the normal path. These are known as deflected alpha particles. Along with this, there are some particles, alpha particles, which undergoes recoil. That means there is 180-degree deflection from its path. That is known as recoil path. So based on this, he made some observation, and based on this observation, he made some conclusion. So now look at it. Let's see what are the observation. Observation of this alpha scattering experiment. Observation number 1. So if you look at this diagram, majority of the alpha particles pass through this metal foil undeflected. So when this metal foil is struck by alpha particles, which is nothing but the positive charged helium nuclei, majority of the alpha particles will pass through this metal foil without any deflection. So the first observation that he observed is majority of the alpha particles pass through the metal foil without any deflection. Majority of alpha particles pass through without deflection from its normal path. Now let's see what is the conclusion that he drawn from this first observation. If majority of the alpha particles are passing through the thin gold foil without any deflection, now since majority of the particles are passing through without any deflection, means the major portion inside this atom is empty, because when these alpha particles pass through this atom, this alpha particle does not encounter any other substance. With these alpha particles does not encountering any other particles inside this alpha atom. So these alpha particles pass through the metal foil without any deflection. That means most of the space inside the atom is unoccupied. So the first conclusion that made from this observation, this is observation number 1, and conclusion is most of the space inside the atom is empty. So since most of this portion inside this atom being empty, this alpha particle does not encounter any other particle inside it. So since without any deflection means space is unoccupied or empty. The second observation that made from this experiment is some of the alpha particles undergoes deflection from this normal path by certain angle theta. So look at this. These alpha particles is deflected from its normal path by some angle theta. These are the alpha particles that is undergoing deflection from normal path. That means some of the alpha particles are deflecting from their normal path. Some alpha particles undergoes deflection from its normal path. Now let's see what is the conclusion that to be obtained or drawn from this second observation. Now these alpha particles are positively charged helium nuclei. A positively charged particle is passing through this metal foil and this undergoes deflection from its normal path. So when a charged particle is moving and after passing through this metal foil, this undergoes deflection. So this deflection would have been possible had there been a similar charged particle present inside the atom. So when these alpha particles, which is positively charged, encounters a positively charged particle inside this atom, so these positive will have undergone the deflection. So the conclusion drawn from this second observation is since alpha particles being positively charged, these are undergoing deflection after passing through this atom. So there must be some positively charged inside this atom, and that positively charged is what we define as the nucleus, and this nucleus is placed exactly at the center of atom, and the positive charge of the nucleus is due to the presence of the proton, that is the fundamental particle which is positively charged. So this conclusion from this second observation is there is a positively charged nucleus placed at the center of atom. So because of this positively charged nucleus, these alpha particles were undergoing deflection from this normal path. So the credit for discovery of nucleus goes to Rutherford's model. So Rutherford discovers the presence of positively charged nucleus, which is placed exactly at the center of nuclei. So this is second observation and second conclusion. So we have a nucleus. So nucleus is positively charged, which is placed exactly at the center of nuclei. Sorry, exactly at the center of atom. This positively charged is due to The protons, so the protons are present actually inside this nucleus, and due to these protons, the nucleus is positively charged, and these alpha particles, when comes near to this nucleus, undergoes deflection by certain angles. That means positive, positive repulsion. So this is, and the volume occupied by this nucleus inside the atom is extremely small if the radius of atom is 10 to the power minus 10 meter, then the radius of nuclei, that is 10 to the power minus 50 meter. That means the volume occupied by nucleus inside the atom is extremely small, and this extremely small nucleus is placed exactly at the center, and this nucleus contains proton, because of which this is positively charged. The third observation he made from this alpha scattering experiment is very few particles, means one alpha particle in 20 alpha thousand alpha particles that is made to strike this metal foil. So 1 in 20,000 means very few number of alpha particles were found to undergo deflection by 180 degree. So deflection by 180 degree, this is known as recoil. So very few alpha particles undergoes recoiling of its path, means deflection by 180 degree. So this is third observation. Very few alpha particles, 1 in 20,000, recoil its path. So what is the conclusion drawn from this theory? Now since these alpha particles, that is very few number of alpha particles undergoing recoiling of each path, that means the centrally placed nucleus is highly rigid. The centrally placed nucleus is very highly rigid, and when these alpha particles approach this nucleus, so those alpha particles approaching this nucleus undergoes the recoil of each path. This recoiling is possible only when this centrally placed nucleus is highly rigid, and most of the mass of atom is concentrated in this extremely small volume known as nucleus. So the observation is very few alpha particles recoil its path, and the conclusion is the centrally placed extremely small nucleus is highly rigid, and the mass of atom is totally concentrated inside this nucleus. Nucleus is highly rigid, and mass of atom is concentrated inside nucleus. So these are the three observations, and from this observation he made three conclusions. So in this Rutherford's model of atom, after this observation and conclusion, he developed a model of atom in which he says every atom consists of a centrally placed nucleus, and this nucleus is positively charged due to the presence of protons. Now these atoms also contains electrons which is negatively charged. So these electrons are moving around this nucleus in circular orbits, such that the electrostatic force of attraction between oppositely charged electron and these electrons are moving in circular orbit because of this electrostatic force of attraction between electron and the proton. The volume occupied by nucleus is extremely small when compared to the size of atom. So if the size of atom is 10 power minus 10, then the size of nucleus is 10 power minus 15. And the entire mass of atom is concentrated in this extremely small size nucleus, which is placed exactly at the center, and the mass of atom is due to protons and the neutrons which is present inside the nucleus. So this is Rutherford's model. So this Rutherford model is compared to the solar system. So we have a nucleus. Around this nucleus, electrons are moving in circular orbit, and this movement of electrons around this circular orbit, in circular orbit around this nucleus, is something like solar system, in which sun plays the role of nucleus and planets are moving around the sun in circular orbits, not exactly circular but elliptical orbits. So these model is sometimes compared to solar system, but there is a major difference between these two. In case of solar system, sun and the planets are very large particles, very large, and these are uncharged, whereas nucleus and the electrons are subatomic particles which are extremely small and they are charges too. So obviously one is uncharged, the other one is charged. One is a very large substance, the other one is very small substance. Next difference is, in solar system only one planet is moving in the circular orbit, whereas in case of atom, more than one electrons are moving in a circular orbit. The next point of difference between solar system and this Rutherford model is, in case of atomic structure, the force of attraction between the particle is Coulombic force, that is attractive force between oppositely charged particles, and this Coulombic force, the magnitude of Coulombic force is between this positively charged nucleus and the electrons, whereas in case of solar system, the force responsible for this movement of planets around the sun is gravitational force. So obviously the magnitude of gravitational force and the magnitude of Coulombic force will differ. So these are some of the difference between the solar system and the Rutherford model. But many of the scientists still compares this is similar to solar system. So we have this experimental setup. We have name of the experiment, the particles used. I will explain you why gold is selectively used, why cannot we use other lighter elements. Then what are the observation, and what, from this observation, what is the conclusion drawn, and based on this observation and conclusion, a model was developed. So this is Rutherford's model. So basic one of Rutherford's model is this: three, observation and conclusion. So this model first of all defines nucleus, which is exactly placed at the center of atom, and this occupies a very small volume compared to the total volume of atom. This theory proves that most of the space inside the atom is unoccupied. Electrons are moving around this nucleus in certain circular orbits, and the attractive force between these two is Coulombic force. The mass of atom is entirely concentrated in a very small volume, that is nucleus, and this is due to protons and neutrons. And the size of atom is 10 to the power minus 10 meter, whereas the size of nucleus is of the order of 10 to the power minus 15. So based on this, we have atomic number. So atomic number of a neutral atom is equals to number of protons present inside the nucleus, which is equals to number of electrons for a neutral atom. So therefore, the atomic number denoted by Z. So Z is equals to number of protons, which is equals to number of electrons, and the atomic mass is the sum total of protons and neutrons present inside the nucleus, also known as nucleons. Number of protons plus number of neutrons present inside the nucleus. This total number of protons and neutrons, this is known as total number of neutrons present inside the nucleus. So atomic mass is represented by A. So A is equals to number of protons plus number of neutrons. For a neutral atom, number of proton is equals to electron, which is equals to atomic number. So we can say this is Z plus N. So atomic mass is total number of neutrons present inside the nucleus, that is proton plus neutron. And this atom is, this is the element or atom, this is atomic number, this is mass number. This is mass number, atomic number, atom of element. So this is the representation of an element. Atomic number, mass number. So we have defined this atomic number, this is mass number. For charged species, if it is a cationic charge, then number of electron is less than the neutral atom. If this is anionic charge, then the number of electron is more than the neutral atom. So let's see some examples. Look at this. Suppose we have look at this carbon 612. So this is atom of an element carbon, atomic number, this is mass number. So this is atomic number, which is equals to J. So this is equals to number of protons equals to number of electrons, that is 6. So the number of electrons in carbon is 6. Number of protons is 6, which is defined as atomic number. This is mass number, which is equals to number of proton plus number of neutron, that is 12. So since number of proton is 6, so therefore number of neutron is 12 minus number of protons, so this is 6. Take this. That is an atom of element iron, atomic number 26, mass number 56. So therefore look at this, J is equals to proton equals to electron, that is 26. The number of electron is 26, number of proton is also 26. This 56, that is mass number, which is equals to proton plus neutron. Now number of proton is 26 plus neutron. So therefore number of neutron is 56 minus 26, that is 30. So this is for neutral atoms. For a charged species, suppose the case, this is S2 minus sulfur with 2 negative charge. So atomic number is 16, that is J. So J equals to number of protons. So number of proton is 16. Now we have 2 negative charge. Negative charge is due to addition of electrons. So therefore number of electrons is, in these localities we have 16. 16 plus 2, that is 18 electrons is present. So but the mass number will remain as this. Mass will remain as it is, 32. So therefore number of neutron is 32 minus 16, that is 16 protons and 16 neutrons is present, but the number of electron is increased. That is, so for every negative charge we'll add 1 more electrons. Take this aluminum, 3 positive, atomic number is 13. So we have 3 positive. Positive charge is due to removal of electrons. So these 13 represents J, that is number of protons. So number of protons is 13. Number of electrons, that is 13 minus 3. So for every positive charge you have to subtract 1 electron. So these contains 10 electrons. Mass number is 27. So mass number 27 means number of neutron is 27 minus proton. So this is how we define number of protons, number of neutrons, number of electrons in a given species. Now based on this, let's try to solve a very interesting problem. Question says an element with mass number 81 has 31.7 percentage more neutrons, 31.7% more neutrons as compared to protons. Find the atom. That means what is the atomic number? We have to define the atomic number. So if you look at this condition says we have an atom of a given element whose mass number is 81, but there are 31.7 more neutrons as compared to the protons. So therefore look at this mass number, that is E. E is equals to proton plus neutron. So this is equals to 81. Now question further says the number of neutrons is 31% more than the number of protons. So we can say this is number of protons plus 31.7% more. So this is total number of neutrons. So combining these two, E, that is 81, is equals to P plus N. N is P plus 0.317 P. So this equals to 2.317 times P. So therefore P is equals to 81 divided by 2.317. 0, 0, 0 divided by 2, 3, 1, 7. So this will come around 35. So proton is 35. So therefore, atomic number which is equals to proton, that is 35. Mass number, that is 81, which is equals to proton plus neutron. So therefore, number of neutron is 81 minus 35. So that is 46. So we have number of neutron is greater than number of proton. So the element is X, atomic number 35, mass number 81. This is nothing but bromine. So this is how we define the atomic number from the given condition. So this is the concept of atomic number, mass number, and the nucleons present inside the nucleus, that is derived from Rutherford's model. Now, though we have discussed Rutherford's model, we give some idea about this atom and how these atoms contains nucleus, what is the position of nucleus, what is the size of nucleus. But there are some demerits of this model. Let's say demerits. Demerits or disadvantage of this Rutherford's model. First of all, this model says electrons with this negatively charged particle, this is moving around this nucleus in circular orbit. So we have electrons moving around this nucleus in circular orbit. But according to classical electromagnetic theory, when a charged particle is moving in a field of opposite charge, it emits energy continuously. So electron is a negatively charged. This is moving in the field of proton, which is positively charged. So every charged particle moving in a field with opposite charge has to emit energy continuously. If electron moving around this nucleus in circular orbit, at each and every turn this will emit energy, and ultimately within a fraction of a second these electrons will undergo spiral path and collide with proton, that is nucleus. That means this theory cannot explain the stability of atom. Cannot explain stability of atom. That means this theory is not in conformity with classical electromagnetic theory. So suppose we have a nucleus, electron is moving. So at each and every turn, this will emit energy, and after within a fraction of a second, this will merge with nucleus. So this is electron. So electrons without losing energy cannot move around a circular orbit according to classical electromagnetic theory. But Rutherford simply says electrons are moving around this nucleus in circular orbit, so we cannot explain why this is not in agreement with classical electromagnetic theory. So experiment says electron moving around this nucleus following this spiral path. This takes place 10 to the power minus 8 seconds. So that means atom could be stable only for 10 to the power minus 8 seconds. So that means this theory cannot explain the stability of atom. Second, if electron is emitting energy continuously at each and every turn, then the observed spectrum would have been continuous. Spectrum means measurement of the frequencies related. So continuous means if electron is emitting energy continuously, so all these frequencies will overlap each other. If the frequencies are overlapping with each other, then this gives you a continuous spectrum. So Rutherford's model says Since electron is emitting energy continuously, the observed spectrum should have been continuous. But the actual spectrum of atoms is discontinuous, containing discrete lines. So the experimental value and the theoretical value does not match. According to this model, the spectrum would have been continuous, but the actual spectrum is discontinuous, that is contains fine and distinct lines. So these theories could explain why spectrum contains distinct lines, but according to model, this should happen a continuous spectrum. So these two again differentiate. The third demerits or disadvantage of this theory, Rutherford's model, is though the theory says electrons are moving around this nucleus in circular orbits, but he never describes or explains in a particular given orbit how many electrons should be placed. That means exact distribution of electrons could not be explained by this model. So that is distribution of electron cannot explain distribution of electrons. So simply says electrons are moving in circular orbit, but in a particular given orbit, how many electrons should be placed? So placement of electrons and the number of electrons to be placed in a given particular orbit cannot be explained by using this Rutherford's model. So these are some of the merits and demerits of this Rutherford's model. So while discussing the demerits, we have come to a particular term, that is electromagnetism or electromagnetic waves. So classical theory of electromagnetism says a charged particle moving in an opposite field has to emit energy continuously, whereas this model cannot explain. So we have to know the concept of electromagnetic waves. So the next part is electromagnetic waves. So let's go to the concept of electromagnetic waves. So let's discuss what is electromagnetic waves. Now, as the name suggests, electromagnetic waves, these are waves which are associated with electric field component and the magnetic field component. And these electric field component and the magnetic field component both are perpendicular to each other, which is also perpendicular to the direction of propagation of light. That means if the wave is moving in this particular direction, that is direction of propagation, then the electric field component is along this and the magnetic field component is along this. So magnetic field and electric field is perpendicular to each other, as well as this is also perpendicular to the direction of propagation of wave. So these types of waves are known as electromagnetic. So name says electro is electric field, magnetic is magnetic field component. So any waves which is associated with electric field component and the magnetic field component, and both are perpendicular to each other as well as perpendicular to direction of propagation of the wave. All these electromagnetic waves moves with constant speed. So electric field and magnetic field are perpendicular to each other and also perpendicular to the direction of propagation. Electric field, magnetic field, both are perpendicular to each other, and this two is also perpendicular to the direction of propagation of the wave. All these electromagnetic waves moves with same speed, that is speed of light. That means for every electromagnetic waves, the speed is always constant, that is speed of light, which is equals to 3 into 10 to the power 8 meter per second. So all electromagnetic waves will be the constant speed. These electromagnetic waves does not require any medium for propagation. Any medium for propagation. So these are properties of electromagnetic waves. So if suppose this is direction of propagation of wave, if this is electric field component, then the magnetic field component will be perpendicular to this electric field component. If suppose this is moving in this way, then the magnetic field component this is electric field component, this is magnetic field component. So both are perpendicular to each other. Electric field, this is magnetic field. Electric field, magnetic field, both are perpendicular. Electric field, direction of propagation perpendicular. Magnetic field, direction of propagation, again this is perpendicular to each other. So these are waves with these characteristics. Now since considering this light is also electromagnetic wave. So all these electromagnetic will show wave character. So if you are having a wave character, then this will have wavelength. This distance, this is crest, this is trough. Distance between any two adjacent place. This is defined as wavelength. So all these will have wavelength, that is lambda. So wavelength is measured in terms of meter. This will also have frequency denoted by nu, measured in terms of, this is in terms of meter, this is in terms of hertz, that is second inverse. And the relation between these two is c, that is speed of light, is equals to frequency into wavelength. Speed of light. So we can undergo interconversion from frequency to wavelength, wavelength to frequency. Then we have wave number, that is wave prime. So wave number, this is defined as 1 by wavelength. So 1 by wavelength is defined as wave number. So this unit should be meter inverse standard unit. So this is the wave characteristic. So light being an electromagnetic wave shows wave behavior. If this is showing wave behavior, then this must have wavelength, frequency, wave number, and all these waves moves with the constant speed, that is speed of light. So we have a number of electromagnetic waves like alpha rays, we have gamma rays, we have cosmic rays, we have radio waves, we have X-rays, visible, ultraviolet, etc. Now these waves can be arranged in increasing order of their wavelength, decreasing order of frequencies, or increasing or decreasing order of energies of different waves. So this arrangement is what we call as spectrum. So spectrum is nothing but the arrangement of these different electromagnetic waves in order of their wavelength or frequency or energy. So I'm giving a brief idea about the spectrum. So in this spectrum we have gamma rays, then we have X-rays, then we have ultraviolet rays, then we have visible spectrum. After this visible we have infrared. After this infrared we have microwaves. After this we have radio waves. Gamma rays, X-rays, ultraviolet, visible, infrared, microwave, and radio waves. So moving from this gamma to radio, wavelength increases. Moving from this gamma rays to radio, since wavelength and frequencies are inversely related, if there is an increase in wavelength, there is decrease in frequency, so frequency decreases. So the maximum frequency is with gamma rays, minimum frequency is with the radio waves. And moving from gamma to radio, energy of radiation also decreases. So this is what we call as spectrum, and this visible contains 7 colors: visual, violet, indigo, blue, green, yellow, orange, red. These 7 colors, that is visible. And for this visible, the wavelength is 400 to 750 nanometer. This is the range in which this visible. So light, being an electromagnetic wave, shows wave behavior. That is, it should contain it should have wavelength, it should have frequencies, wave number, etc. So considering light as a wave, that is light being an electromagnetic wave, so considering this wave nature, so this wave nature of light explains the properties like interference, reflection, refraction, diffraction, etc. So some phenomena of light like interference, reflection, refraction, diffraction, these properties of light could be explained by considering light as a wave nature. But there are certain properties of light which cannot be explained by this Hubble measure. So these cannot explain photoelectric. These cannot explain photoelectric effect. These cannot explain line spectrum. These cannot explain variation of heat capacity. Variation of specific heat with temperature or black body radiation. So, when we consider light to be electromagnetic wave, this could explain some of the properties of light. That properties are interference, reflection, refraction, diffraction. But there are many more properties of light which cannot be explained by considering wave nature of light. So, those properties are photoelectric effect, line spectrum, variation of specific with temperature, or black body radiation. So these are the properties which cannot be explained by wave nature. So those properties which cannot be explained by wave nature, we have to find some other ways to explain. So considering this, light shows dual property, that is wave as well as particle nature. So to explain this, we'll take help of black body radiation. So let's see what is black body and what is black body radiation. So black body is an ideal body which can absorb all the frequencies falling on it and simultaneously can also emit all the frequencies. That ideal body which can absorb and emit all the frequencies is known as black body, and the radiation emitted by a black body is known as black body radiation. So we have this black body, that is an ideal body which can absorb and emit all frequencies. So their idealized body which can theoretically absorb all the frequencies falling on it and also simultaneously can emit all the frequencies, that is known as black body. And the radiation emitted by a black body is known as black body radiation. Is known as black body radiation. So we have, look at this, take this example. So we have this iron Fe. Now we heat this iron. On heating this iron, first this changes to dull red. On heating further, this changes to red hot, means intensity of red color increases. On heating further, this changes to white, and heating further, this changes to blue color. That means we are having the same substance, iron, we keep on heating at various temperatures. First, this changes to dull red, then this changes to intense red. On heating at for higher temperature, this changes to white color. On heating again, and this changes to blue color. So, in terms of frequency, in terms of frequency, as the temperature increases, frequency is moving from low frequency to high frequency. As the frequency increases, energy also increases. That means when we heat a particular substance, as the temperature increases, the frequencies of the radiation emitted increases, or the frequency of emitted radiation is moving from lower frequency to higher frequency. So in terms of frequency, this is moving from lower to higher. Well, we have just explained, that is V pure. So in terms of frequency, moving from this frequencies decreases. So when heating this substance iron at various temperatures, moving from the red to blue. That means this is moving from lower frequency range to higher frequency range. So these black body radiation shows we are having same substance. The same substance keep on heating. As the temperature increases, frequency of emitted radiation also increases, or wavelength decreases. As the frequency increases, energy of radiation also increases. So this variation is explained through this graph. It is energy versus wavelength. So suppose this is at T1. At T1 we have this. This is, now look at this. The distribution is not uniform, but this was the maximum at a particular wavelength, and on either side there is. So initially the intensity increases, reaches a maximum point, and after this maximum point again intensity decreases. Suppose this is at T2. This is at T3. This is at T4. Moving from T1 to T4, temperature decreases. So as the temperature increases, the frequency decreases. Frequency increases. So frequency increases means wavelength decreases. So moving from lower temperature to higher temperature, intensity of radiation emitted increases. If the intensity increases means frequency increases, or wavelength decreases. So this black body radiation, this changing the intensity of emitted radiation or energy of the radiation with frequency or wavelength at different temperatures could not be explained by this wave nature of light. So to explain this black body radiation, Max Planck introduced the concept of quantum theory. Or simply known as Planck's quantum theory. So Planck's quantum theory says when this substance absorbs or emits radiation. This absorption or emission cannot be a continuous process. This must be a discontinuous process in the form of discrete particles, that is small packets of energy. So the postulates of this Planck's quantum theory says absorption or emission of energy is not continuous but is discontinuous. So absorption of energy by the substance or emission of energy by a substance cannot be a continuous process. This has to be a discontinuous process, and this continuous process, the form of discrete or small packets of energy. In the form of discrete or small packets of energy. This continuous process or absorption or emission of energy in discrete or small packet, this is what we call as quantization of energy. Quantization of energy. That means energy is quantized or energy is in the form of small discrete packets. Since this is in the form of small discrete packets, this absorption or emission cannot be a continuous process, but it has to be a discontinuous process. That is, energy is always quantized. The second important postulate of this quantum theory is the smallest packet of energy is known as quantum. So quantum is the smallest packet of energy. The smallest packet of energy is defined as quantum. If the radiation happens to be light, so for this light, this quantum is defined as photon. The smallest packet of energy of light, that is known as photon. So absorption or emission of energy by a particular substance is the form of quantum, that is quantized energy packets. Now if the energy in the form of light is used, then energy is in the form of photons, that is smallest packet of energy of light is known as photon, and photon is nothing but the quantum. Quantum is a generalized, photon is specific for light. The third postulate of this Planck's quantum theory says the energy of photon is directly proportional to frequency of light. Energy of photon is directly proportional to frequency of light. That is, energy of single photon is E. So this is directly proportional to frequency of light. So therefore, look at this. We remove this constant proportionality, then a constant comes, that is E is equals to H nu. So this H is known as Planck's constant. So which has a value 6.6 into 10 to the power minus 34 joule second. This is the standard unit of H, Planck's constant, 6.6 into 10 to the power minus 34 joule second. Frequency is measured in terms of second inverse, that is hertz. Therefore, E has the unit of joule. Now we have to look at this. E is equals to H nu. So this can also be written in terms of wavelength. So h c by lambda. So we have this c is equal to frequency into lambda. So this is wavelength. This is speed of light. So that means if suppose we have two different light, then we can have two different energies. So E1 is equal to S is equal to Hc by lambda 1, E2 H nu 2 Hc by lambda 2. So therefore, because E1 by E2 is equal to mu1 by mu2 which is equal to, this is the ratio. Or if suppose we have this, if E total is equal to E1 plus E2, then look at this. Here is H nu is equal to H nu1 plus H nu2. So this is nu is equal to mu1 plus mu2. Or in terms of frequency, you can say C by lambda is equal to C by lambda 1 plus C by lambda 2. Or we can say 1 by lambda is equal to 1 by lambda 1 plus 1 by lambda 2. This is the relation between wavelength. If total energy is sum of two energies of light, that is E1 and E2. So, according to Einstein theory, so this energy which is equal to h nu, which is equal to h c by lambda, that is Planck's equation, and the same energy of light according to Einstein, this is equal to m c square. So since the energy, this is the energy of same substance, that is light, so therefore this h nu is equal to m c square, or we can say h c by lambda is equal to m c square. So Einstein theory says in a light possess particle nature. This says that possess wave nature. So that means this light possess dual character. So the dual character is known as dual properties of light, wave as well as particle nature of light. So the wave nature, this wave nature explains interference, reflection, diffraction, etc. Whereas the wave nature could not explain some phenomena like black body radiation, variation of heat capacity with temperature, photoelectric effect. So those phenomena which cannot be explained with this wave nature were explained by this particle nature. So from this point we come to the conclusion if light possesses the dual properties. So this is Planck's quantum theory. So this theory says energy is directly proportional to frequency or inversely related to wavelength, and the total energy is equal to n h nu. N is number of photons, h is Planck's constant, nu is frequency. So from this we can also define number of photons. So number of photons is total energy divided by energy of single photon, that is H, that is energy of single photon, and this is total energy. So based on this, let me give you some examples how to solve this problem. We use this equations. If two photons with wavelengths two thousand nanometer and lambda to 6000 nanometer, then what is the ratio of their energies? So we have two photons with wavelengths 2000 nanometer and 6000 nanometer. Then what is the ratio of their energies? Now I've just shown you this energy ratio is equal to frequency ratio, which is inversely related to wavelength ratio. So therefore look at this, we have this energy ratio is inversely related to wavelength ratio. So therefore E1 by E2 is equals to lambda 2 is 6000 into 10 to the power minus 9 meter. Lambda 1 is 2000 into 10 to the power minus 9 meter. So this comes out to be 3 to 1. Second question. How many photons of wavelength 2000 nanometer, how many photons of wavelength 2000 nanometer will give 1 joule energy? So total energy is 1 joule. Wavelength of each photon is 2000 nanometer. So how many photons are present? So we have this relationship. Total energy is equals to N into energy of single photon. So we have N is equals to total energy by energy of single photon. So this is ET by Hc by lambda. So therefore number of photon is lambda into total energy divided by Hc. So lambda is 2000 into 10 to the power minus 9. Total energy is 1 joule divided by H is 6.6 into 10 to the power minus 34. C is 3 into 10 to the power 8. So this gives you total number of photons that will yield 1 joule energy. So this is Planck's quantum theory. So from this Planck's quantum theory, we can define energy if frequency is given, or we can also define frequency if energy is given, or energy into wavelength, or wavelength into energies, or the ratio of energies, or number of photons if total energy and the frequency or wavelength of each photon is mentioned. So this is quantum theory. So this Planck's quantum theory for the first time introduced the concept of quantization of energy. After this quantization of energy, that is energy being quantized, we come to the photoelectric effect This photoelectric effect was given by Einstein, for which he was awarded Nobel Prize. So let's see what is photoelectric effect. Now, when a light of proper frequency falls on the surface of metal, so we have a metal, and some light of proper frequency falls on the surface of metal. When light with proper frequency falls on the surface of metal, electrons are ejected from the surface of metal. So this phenomenon of ejection of electrons from the surface of metal when a light of proper frequency falls on it is known as photoelectric effect, and the ejected electrons are known as photoelectrons. Definition is the phenomenon of ejection of electrons from the surface of metal when a light of proper frequency falls on it. So this phenomenon of removal or ejection of electrons from the surface of metal when a light of proper frequency falls on it is known as photoelectric effect, and ejected electrons are known as photoelectrons. After ejection of this electron from the surface, electrons are moving with certain velocity, then ejected electrons are known as photoelectrons, and the phenomenon for this ejection of electron by use of frequency of light is known as photoelectric effect. So suppose we have a metal surface. On this metal surface we have thousands of electrons, and these light, a light of particular frequency falls on the surface, and this surface remove this electron. That is incident light, that is ejected electrons. So when light falls on the surface of metal, metal contains a number of loosely bound electrons. Loosely bound electrons are also known as valence electrons. Valence electrons or loosely bound electrons. So these electrons being loosely bound, the energy of incident light is used to break this force of attraction between electron and the nucleus. After this breaking of attractive force between this electron and nucleus, electrons are completely ejected from the surface of metal. This is what we call as photoelectric effect. So during this photoelectric effect, you are supplying energy on the surface of metal. So this is the total energy that is coming from incident light. After this incident light, some of the energy is used for breaking this attractive force between nucleus and the electron, and the remaining energy is converted into kinetic energy of ejected electrons. So the energy required to break the attractive force between electron and the proton, electron and the nucleus, that is known as binding energy, and this is what is minimum energy. That means for this photoelectric effect, you have to supply some energy greater than or equals to minimum energy. And after this, the excess energy is converted into kinetic energy of the ejected electrons. So this is the phenomenon of photoelectric effect. So valence electron or loose bound electron is to be completely removed. For this, you have to supply energy, and this energy must be greater than the minimum energy required to break this effective force between electron and the proton. So we have some term, that is work function. This is also known as threshold energy, or which is also known as critical energy. So we have a term work function or threshold energy or critical energy. So this work function or threshold energy or critical energy, this is the minimum energy required to eject electrons from the surface of metal. That minimum energy required, if the energy supplied by this incident light is less than this minimum energy required for ejection of electron, no more photoelectric effect is observed. So for this photoelectric effect to be observed, the incident light energy must be greater than this minimum energy, and that minimum energy required is known as work function or threshold energy or critical energy. So we have this work function. Sometimes this work function is divided by W naught or sometimes by phi. So this work function or the minimum energy or the critical or threshold energy, this is equals to the binding energy of electron. So binding energy of electron is nothing but the force of attraction between electron and the nucleus. Attractive force between valence electron and nucleus. So this is the minimum energy required. So you have to supply some energy which must be greater than this minimum energy. So this minimum energy is given by different name: threshold energy, critical energy, binding energy, which is nothing but the attractive force between the valence electron and the nuclei. Now we have this work function, threshold energy, critical energy, and the frequency corresponding to this work function or the critical energy or threshold energy is known as threshold wavelength. Threshold or critical frequency. So this is a minimum frequency of incident light for photoelectric effect to occur. Minimum frequency required for photoelectric effect. So what is the minimum frequency of incident light required for this ejection of electrons from the surface of metal? That frequency is known as critical or threshold frequency, and energy corresponding to this threshold energy or critical energy frequency is known as work function or threshold energy or critical energy. So we have this. So you are supplying some total energy. From this total energy, some energy is used to break this attractive force between electron and nucleus, that is known as binding energy or work function or threshold energy, and the remaining energy is converted into ejected electrons. Sorry, kinetic energy of ejected electrons. So according to conservation of energy, So from conservation of energy, from conservation of energy, so total incident energy is equals to minimum energy plus excess energy in the form of kinetic energy of electron. So this is the equation. So total energy, that is T total, is equals to minimum energy, that is work function, plus kinetic energy. So total energy is H nu. This is incident light frequency. That is work function. This is minimum frequency required, that is critical frequency or threshold frequency, plus kinetic energy. So therefore, kinetic energy of ejected electrons is equals to total energy minus minimum energy, that is work function. So this is in terms of frequency. We can say Hc by lambda, that is incident light wavelength, Hc by lambda naught. So this is in terms of frequencies, this is in terms of wavelength of light used, and the minimum wavelength of light required for ejection of photoelectrons. So look at this, we have this kinetic energy, that is the equation A, this is equation D. We have kinetic energy is half m v square, while this is the mass of electron, velocity of ejected electron. Mass of electron, velocity of ejected electrons. So this velocity possessed by ejected electron is the maximum. So we can say this is maximum kinetic energy. If the kinetic energy is maximum, this is the maximum speed. So this is equals to h nu minus h nu naught, or we can say hc by lambda minus hc by lambda naught. Or we can say, look at this, from this we can define the velocity. So therefore, velocity square is equals to 2 times h by m nu minus nu naught. This is the velocity. Or we can say 2 times hc by n, 1 by lambda minus 1 by lambda. This is how we define velocity of ejected electrons. So we have this equation is said total incident energy is work function minimum energy plus excess energy in the form of kinetic energy. So look at this graph, equation A. This is kinetic energy. Now if you look at this, if the frequency of incident light is 0, kinetic energy is negative h naught. This is kinetic energy 0, negative, positive. This is frequency of incident light. So if the frequency of incident light is 0, kinetic energy is minus h nu naught. Then if the frequency is increased, and after this, so this particular frequency, that is known as nu naught. So you have to supply energy corresponding to this nu naught. If the energy is less than this nu naught, then no photoelectric effect. If the energy is greater than, then there is ejection of electron. So this is kinetic energy versus frequency graph. And this y-intercept, this is slope slope is equals to tan theta, which is equals to, from this graph, slope is h. So for this graph, slope is equals to h, that is Planck's constant, and this y-intercept, is equals to h mu naught. This is for equation A. This is kinetic energy 0, positive, minus. Now in terms of frequency wavelength, by 1 by wavelength. If the graph is between kinetic energy and wavelength, electric dimension, except is slope. So if 1 by wavelength is 0, kinetic energy is minus hc by lambda naught g, and this increases, and beyond this again, this is again slope, which is equals to tan theta, but slope is here at c, and this y-intercept, this is minus hc by. So from this intercept we can define the value of lambda naught. From this slope we can define hc. Then we can easily construct this. This is equation A. This is equation B. So this is the equation that is used in case of photoelectric effect. Now, though we have discussed photoelectric effect, why metals are showing photoelectric effect? Because metals have loosely bound electron which can be easily removed provided energy is better and minimum energy is supplied. Now this photoelectric effect basically is used in photoelectric cells. So photoelectric cells, solar cell, that is most common nowadays. The solar cells is based on this photoelectric effect. So the solar cells contains a number of panels, that is a cell. This cell contains this metal. When light falls on this surface, electrons are ejected. Because these electrons ejected is going through the circuit, because of flow of electron, there is current generated, and that current is stored in battery. So during daytime, there is continuous ejection of electron, and electron is moving in the external circuit, and current is generated, that is stored in the battery. When the supply of light is cut off, no more ejection. If there is no more ejection, there cannot be generation of electricity. So in that particular case, energy stored in in battery is converted into electrical energy. That is the basic principle of photoelectric cells. Now, ejection of electron is required. So ejection or removal of electron is known as ionization. So only those metals which have low binding energy or low ionization energy finds its application in photoelectric cell. So most of the case, alkali metals like potassium, rubidium, cesium, these are the elements with low values of ionization energy. Cesium is the metal which is the having lowest value of ionization energy. So cesium finds application in photoelectric cell because the cesium is the element having least value of ionization energy. Least energy is required for ejection of electrons from the surface of cesium. So cesium is used in photoelectric cell because its ionization energy or work function is least. So we have this. Now sometimes energy is also expressed in terms of stopping potential. Stopping potential is the potential that must be applied so that there is no photoelectrons. So when light is falls on the surface of metal, electrons are ejected. So where there is a photoelectrons, because of this ejection of electron, photoelectric effect occurs. Now we apply some force from outside. such that there is no ejection of electron. So the force or the energy required to stop photoelectric effect, that is known as stopping potential. So that stopping potential must be equal to kinetic energy. So based on this, kinetic energy, that is half mv square is equals to E into V naught, that is charge of electron. Electronic charge, that is 1.6 into 10 to the power minus 19 coulomb. This is stopping potential or voltage. So, so this is nothing but the potential that must be applied so that there is no ejection of electrons. So sometimes kinetic energy is measured in terms of stopping potential. In terms of this, we have this kinetic energy is equals to h nu minus h nu naught. This is work function. So this kinetic energy, so this is half mv square, that is h nu minus work function. So mv square is ev naught. This is equals to h nu minus naught, or stopping potential is h by e v minus w naught by e. If w is also h nu, so we have h nu by e minus h nu naught by e, or we can say h by e u minus nu naught. So if you make this graph, that is stopping potential 0, positive, negative, versus frequency. So if you make this graph, then this is theta. So therefore slope is equals to h by e, and this y-intercept, this is equals to h nu naught by e. So the only difference is the slope. So if you look at this, slope is h by e. So take the ratio, vertical is electronic charge. So this is kinetic energy, which is measured in terms of stopping potential. So both are same. So the only difference of concept is required. There is electron charge into stopping potential or voltage. So this is photoelectric effect, but there are certain laws for this photoelectric effect to occur. So those, let's see the laws of photoelectric effect. Laws of photoelectric effect. So though we have to discuss what is photoelectric effect and what is the application, what are different terms that is involved in photoelectric effect, and how to define the velocity, how to define the kinetic energy, how to define the work function. Now there are laws which govern this photoelectric effects. Let's see those laws. So when a light or a photon falls on the surface of matter, electrons are ejected. So the law says only one photon can eject one electron at a time. That means there is a 1:1 ratio. One photon, one electron is to be ejected, provided energy of photon is greater than the minimum energy. One photon cannot eject more than one electron. So the first law is one photon of proper energy can eject one electron at a time. So we have 1:1 ratio. So don't say okay, one electron will eject, sorry, one photon will eject more than one electron if the energy of the photon is greater than minimum energy. So one photon has to eject one electron at a time. Second law, this says now photons are falling on the surface of metal and electron is to be ejected, and some of the energy that is supplied by this photon will be used up for this breaking of the binding energy, and the rest energy is converted into kinetic energy of ejected electrons. So during this process, there is no time lag between the fall of photon and ejection of electron. That means when the photon falls on the surface, this energy will be used up by electron to break this attractive force, and finally electron is ejected. So this process, there is no time lag. The moment photon falls on the surface of electron, electron has to be ejected. So no time lag between the fall of photon no time lag between the strike of photon and ejection of electron from the surface of metal. So there should not be time lag. Number 3. Now energy is supplied to the electron by photon, and this energy is used up for breaking of bond between electron and nuclei, and then the rest of the energy is converted into kinetic energy. So the kinetic energy of electron is directly proportional to the energy of incident light. If frequency of incident light is more, so we can have more energy that is converted into kinetic energy, because the work function is always fixed for a particular. So there is no time lag between the strike of photon and ejection of electron. Third, kinetic energy of ejected electron is proportional to frequency of incident light and is independent of intensity of light. Number 4, the number of photoelectrons ejected. The number of photoelectrons ejected is proportional to intensity of light, but is independent of frequency. So how many electrons to be ejected depends on intensity. That means the light with proper frequency, if the intensity is different, more intense light will eject more number of electrons. If the intensity of light is less, that means dim light will eject less number of electrons, provided the frequency is above this minimum frequency. So kinetic energy depends on intensity, incident light, but independent of intensity. Number of photoelectrons ejected depends on intensity, but independent of frequency. And for all these photoelectric effects to occur, the frequency of incident light should be greater than or equals to minimum frequency, that is critical frequency. If the frequency of light is greater than the frequency, only then ejection of electrons. If this minimum frequency equals to instant frequency, then ejected electron kinetic energy will be 0. So these are the rules which has to govern the photoelectric effect. So we have look at this. Kinetic energy is proportional to incident light, but intensity of light is independent. So we have this. kinetic energy of jet electron and intensity of light. So kinetic energy has nothing to do with intensity of light, so kinetic energy will always be constant. Keep on increasing the intensity, kinetic energy will remain same. But if number of electrons is to be same, then as the intensity increases, number of electrons rejected increases. So this is photoelectric effect. What is photoelectric effect? How photoelectric effect occurs? What is the condition? What is the inner equation? What are the different graphs? What are the different terms used? And what is laws of photoelectric effect? Hopefully we get a class. Thank you.